Hello, dear children. This is video 2 of circles lesson. So in video 1 I had just started circles lesson and I came to the point that tangent is a line which touches the circle at only one point, and that point is called as point of contact. And through the point of contact, if a radius is drawn, then I had told you that radius will be perpendicular to the tangent, or the tangent will be perpendicular to the radius drawn through the point of contact. This is a very important property of a tangent, that whenever there is a tangent to the circle, it will have a point of contact because it is the point where it touches the circle. Through that point, if you draw a radius, that will be perpendicular to the tangent, or tangent is... So I am repeating this. Why? Because it's a very important property. You should always remember this. So radius through the point of contact drawn will be perpendicular to the tangent. So what is the meaning there? Angle OPB. See, I have drawn a figure there. I had drawn this figure. Angle OPB is equal to 90 degrees. Angle OPA is also equal to 90 degrees. These two angles will be 90 degrees. This is an important property. You have to remember this. Now next point is another point I told you. On the circle, at any point on the circle, you can draw only one tangent. That also is quite an important point. Okay. Of course, you are going to come across some other point, some other related to this. But afterwards, you are going to learn one property now, which you have already just now heard. We are going to prove it as a theorem, actually. So we are going to prove that radius through the point of contact drawn to a tangent, no, it is perpendicular to the tangent. That is the statement of the theorem. But in order to prove that theorem, you should know something which you have already learnt in 9th or 8th. Somehow in lower classes you have studied this. I don't know, I cannot tell you which class and all. So if there is a circle like this, so I am going to, first of all, we should know this point. Before proving the theorem, we should know this point. What I am telling now, you please try to understand. Now see, let there be circle, but before that only I am going to draw, I am going to take a point, say a point or any point, and then there is another line here, there is another line here, and from O, if you join points on this line, say XY, I'll take a point OP now, P here, and join OP, take another point here Q and join OQ. So like this, if I go on joining different points on XY to O, no, there will be many lines. There will be many lines. I can draw some lines like this. See here, P, Q, R, S, T. Like this, I will give a name. Now you will see this here in the figure. Out of all, there are so many lines here. I have drawn 5 lines here. Say there are many lines still we can draw. Among all these lines, OS will be the shortest. You please observe in the figure. OS will be the shortest distance from O to any point on XY. So OP will be bigger than OS, what I have drawn here. OP, OT, OR, OQ, all these lines will be longer than OS, or OS will be the shortest distance, we can say, or it is the shortest distance from O to S. So S is such a point that OS is the shortest compared to other lines. So if it is the shortest, no, this will be a special line actually. What it will be? It will be perpendicular. It will be perpendicular to XY. All the other lines which are drawn here, they are longer than the perpendicular. So perpendicular means it is the shortest distance from O to that to some point on that line. any point means you can't take any point. Say you have taken other points R, Q, T, P and all, but when you join it to O, they all seem to be longer than this OS, and OS is considered to be the shortest distance. Shortest distance from O to XY. So shortest distance will always be a special line. It will be perpendicular only. It will be perpendicular to XY. So this point we require to prove our theorem today. This theorem in circles. So now I have just explained the shortest distance is the perpendicular and all. Now I am going to come to the theorem. So theorem I have just here I am just going to explain here. So theorem 1 circles, you are going to write this theorem along with me if possible. I will just dictate here only. I will go on telling, you have to write down actually. But of course I'll just first explain the theorem if you want. So statement I have written, you see here, the tangent at any point of a circle is perpendicular to the radius through the point of contact. So this is a statement, it has been heard now many times. So in the statement of the theorem, there will be two parts I have told you. The first part that is given, and the last part is always for us to prove. So the tangent at any point of a circle, till here it is given to us. Means what? A circle is given and a tangent is given at some point on the circle. Now that the tangent at any point of a circle, we are going to prove that it is perpendicular to the radius through the point of contact. So, and I told you conversely also it is true. So this is the statement of the theorem. Don't think about the converse and all now. I just told you we are not going to prove the converse and all. We are just going to prove this theorem. And see, accordingly I have to draw a figure now for the statement. According to the statement I have to draw the figure. See, O is the center of a circle I have drawn. And XY is a tangent, okay, at a point P. XY is the tangent at a point P and O is the center of the circle. Okay. Now what will be the data? Data is what we have drawn in the figure, we have to write there in data. So see, it's very simple. What we have drawn in the figure, XY is a tangent to the circle with O as center at P. XY is a tangent to the circle with O as center at P. So this is what we did in figure, we have written in data. Now to prove that is what? OP is perpendicular to XY. The meaning is XY is perpendicular to OP. Same thing it is. So OP is perpendicular to XY, we have written. Now construction we need to prove this theorem, we need a simple construction. Okay. The construction is, take a point Q on XY. See, you can see in the figure, you have got in the textbook also the figure. If you have kept there in front of you, you can follow there. So even what I have given here, you just see and you are going to write accordingly. What I have written, I will give you. You have to write fast. So XY is a tangent to the circle with O as center at P. Then to prove that is what? OP is perpendicular to XY. Now construction is, take a point Q on XY other than P and join OQ. See, dotted lines I have drawn there. Dotted lines I have drawn to show that it is construction. Now this theorem is something not very, very simple, because we have already proved that point I have told you, shortest distance, just before the theorem I told you. That point we are going to use here. How we are going to use, you see now. Now proof starts. Okay. Since Q is a point outside the circle, OQ is longer than the radius. Please see and try to understand what I am telling. It is greater than the radius. It is longer than the radius. OP of the circle. OQ is, you can see there, OQ is bigger or greater than OP. So that is, what is the meaning? OQ is greater. That sign you should know, symbol. greater than OP. Greater than OP I have written here. Now since this will happen for any other point also, if you take any other points on XY, leaving P, if you take any other points here, so many points are there, if you want you can take, but all of them when you join to O, they will be greater than OP only. So since this will happen for every point on the line XY except the point P, OP will be what it will be? It will be the shortest of all the distances of the point O to the points of XY. So you can take any point here, they will all be, when you join it to O, that is the explanation what I am giving, they will all be greater than OP. So since they all will be greater than OP, what is the meaning? OP will be the shortest there. It will be the shortest of all the distances of the point O to the point XY. So shortest distance, you know, it is already, you have learnt in lower class, I told you, it is nothing but perpendicular line. So OP is perpendicular to XY. So the proof is very, very simple. The only thing is you should understand it properly and you can write in your own words. So you should know OQ is greater than OP and this will happen for all other points on XY. Therefore, OP will be the shortest of all those lines. That is the meaning is that shortest distance is always perpendicular. You have learned this property in the lower classes. So that we are using here. So OP is perpendicular to XY, or OP perpendicular means we write the symbol now, OP perpendicular to XY, and lastly we write there proved. The theorem is proved. So this is the theorem. Okay. You only thing is, first of all you should understand it and then you can easily write. Okay, children. So if you have taken down points, okay. So statement I told you, figure what you should do. So you can, I think, even write when you look at the video, after when you look at the video 2-3 times, you will be able to see what I have written there and you can write in your fair books. Okay, so you can write. See, I am just showing you like this and you must be able to write the theorem. Okay, then let me see the time. It's already 12 minutes. Okay, then next property we are going to do now. So theorem, I think you can see the video and you can write. Okay, now come to the exercise 4.1. To the exercise 4.1, I am keeping the textbook here. Exercise 4.1 we shall see now. So you have to do this exercise. Of course, first of all you have to write the points. Then simple points I told you, and then you have to, need not do all the diagrams what is given there, not at all necessary. What is required you do, that much only, and then come to the theorem, write the theorem and then start the exercise 4.1. Now how many, this one I had already discussed, how many tangents can a circle have? So I hope you know the answer. Infinitely many tangents can be drawn, because the question is like that. It's not given at a point on the circle. If it was given at a point on the circle, then you should have, you should say only one tangent. But here it's not like that. Can a circle mean circle has got number of points, lots of points, or infinitely points? At every point you can draw a tangent there. So that is the meaning. Okay, now fill in the blanks. Fill in the blanks. What does it say? A tangent to a circle intersects it dash a point. Only one point. A tangent to a circle intersects it in. Tangent means it will touch the circle at only one point, or only one point will be common to both of them. That is the meaning. So only one. Then second, a line intersecting a circle in 2 points is called a dash. What will you say? A line intersecting a circle, which passing through the circle in 2 points is called a. By this time you will have written the definition and all. So you know it. It is a secant. It's a secant. A circle can have dash parallel tangents at the most. A circle can have parallel tangents at the most, number of infinite actually, but parallel tangents at the ends of a diameter you can draw, that's all, because diameters, any number of diameters can be drawn, you know that, any number of diameters. So at the ends of the diameters you can draw, if you draw two tangents, no, they will be parallel to each other. So I hope you understood the meaning, and that is what you have to write, you came to know. The common point of a tangent to a circle and the circle is called dash. The common point of a tangent to a circle, the common point, the point which is common to the tangent also and the circle also. What is that called as? It is nothing but point of contact. Okay, then third one, a tangent PQ at a point. So you please see this one. The tangent, I'll show you. It's very easy. It will come for MCQ and all. It's an MCQ given here. A tangent PQ at a point P of a circle of radius 5. So radius 5. So I won't draw the circle of 5 and all. Now actually it is time up. Let me continue in the next. Okay.